Every smartphone on Earth vanishes tonight. Not just the devices, the factories, the supply chains, the mines, the engineers, all of it gone. Starting from scratch, one question remains: how long would it actually take humanity to rebuild even a single one? The answer is not years, it is not decades. The honest answer, depending on where you start, is somewhere between several centuries and never. A modern smartphone contains roughly 60 distinct elements from the periodic table. It contains more precise engineering than the entire Apollo program did in 1969. It connects to satellites, bounces signals off towers, and runs software written by tens of millions of people across 7 decades of accumulated knowledge. And most people carry it in a pocket, next to their keys. Start at the very beginning, before the phone, before the factory, before even the concept of a factory. And the first wall you hit is raw materials. The glass screen alone requires silicon dioxide, soda ash, and aluminum oxide, melted together at over 1,600 degrees Celsius, then chemically strengthened in a potassium salt bath. That process, the one behind Corning's Gorilla Glass, was developed over decades and requires furnaces, chemical supplies, and quality control systems that simply do not exist if you are starting from a pre-industrial base. Then there is the copper. A single smartphone contains roughly 15 grams of copper, drawn into wires thinner than a human hair, woven through circuit boards with tolerances measured in micrometers. To get that copper, you need a working mine, a smelter, a refinery, and the ability to draw metal into wire at extreme precision. None of this is trivial. The Chilean Atacama Desert, which produces around 28% of the world's copper today, runs on infrastructure that took over a century to build. Now add lithium. The battery in a modern smartphone is a lithium-ion cell, and lithium itself is one of the rarest commercially extracted metals on Earth. The lithium triangle, covering Chile, Argentina, and Bolivia, holds around 58% of global reserves, but extracting it requires evaporation ponds, chemical processing plants, and industrial-scale water management in one of the driest places on the planet. So before you have even touched a single electronic component, you have already needed a global mining industry, a chemical processing industry, and a glass manufacturing industry. And the phone still does not exist. Now comes the part that genuinely breaks the math: the microchip, a modern smartphone processor. Apple's A-series chips, Qualcomm Snapdragon line, is built on transistors that are measured in nanometers. The latest chips pack over 15 billion transistors into a piece of silicon roughly the size of a fingernail. To put that in perspective, a single human red blood cell is about 8,000 nanometers wide. The transistors on a modern chip are 3 nanometers across. You cannot see them under an optical microscope. Light itself is too coarse an instrument. To build them, manufacturers use a process called extreme ultraviolet lithography, where light with a wavelength of just 13.5 nanometers is generated by firing laser pulses at tin droplets and then bouncing the resulting plasma flash off a series of mirrors polished atomic-level smoothness. The machines that do this, built by a Dutch company called ASML, weigh roughly 180,000 kilograms, contain over 100,000 individual components, cost approximately $350 million each, and took the combined engineering effort of over 5,000 supplier companies across multiple continents to design and manufacture. There is currently no substitute for them. There is no shortcut. There is no version of this process that can be replicated in a garage or even a reasonably well-funded university laboratory. The silicon itself, the raw material inside every chip, must be purified to 99.99999% purity. That is 9 nines. A single stray atom of the wrong element in the wrong place can corrupt an entire circuit. Achieving that level of purity requires a process called the Chokrovsky method, where high-purity silicon seed crystals are slowly pulled from a molten silicon bath in a precisely controlled atmosphere, growing a perfect single crystal ingot that is then sliced into wafers thinner than a strand of hair using diamond tip wire saws. The machines, the chemicals, the controlled clean rooms, all of it requires a civilization that is already running. And this is the core irony. The smartphone is not actually the hard part. The hard part is that building a smartphone requires the existence of tens of thousands of supporting technologies, each of which was itself the product of centuries of incremental scientific progress. The transistor was invented in 1940. 7 at Bell Labs by a team that had spent years studying quantum mechanics, a field of physics that did not even exist before the 1920s. Quantum mechanics itself was built on the mathematics of the late 1900s, which was built on the calculus developed by Newton and Leibniz in the 1600s, which was built on the algebra that arrived in Europe from the Islamic Golden Age scholars of the 9th and 10th centuries. Every layer requires the one beneath it. When historians study the smartphone as an artifact, they do not describe it as a product of one company or one country. They describe it as the current endpoint of a civilizational relay race. 10,000 years of humans passing knowledge forward, each generation handing off slightly more capability than it received. The metallurgy that gave us copper wires stretches back to the Bronze Age. The optics behind the camera lens traced to Islamic scholars of the 11th century. The mathematics driving the GPS chip were worked out by Einstein in 1915. The software protocols that connect every phone to the internet were designed in the 1970s by ARPA researchers building a military communication network that they imagined might one day carry text messages between universities. None of them imagined a pocket-sized device. None of them imagined 4 billion people connected simultaneously in real time. And yet here we are, holding the end product of all of it, every single day in one hand, usually while doing something else entirely. The realistic estimate from historians of technology is that a civilization rebuilding from a pre-industrial base, with all existing scientific knowledge preserved in books, could reconstruct something resembling a basic semiconductor by the early 22nd century, assuming no major disruptions. A full modern smartphone with its camera, GPS, cellular radio, and multi-billion transistor processor is a project measured in multiple generations of sustained effort. That means the object in your pocket is not just a consumer product. It is the physical compression of roughly 10,000 years of human curiosity, failure, cooperation, and compounding knowledge into a slab of glass and metal that fits in a jacket pocket. No single person on Earth could build one alone. No single country, starting from scratch, could build one within a human lifetime. The smartphone is the most complicated object most humans will ever casually touch, and the fact that it costs less than a month's groceries might be the most extraordinary economic fact of the modern age. The civilization that built it took millennia. The civilization that could rebuild it would need to be just as patient.